Hi, I'm Lam, and this is the presentation for this week about stepwise regression and multicollinearity in correlation and regression lectures. So, stepwise regressions is a method of fitting regression models in which the choice of predicted variables is carried out by an automatic procedure. So the purpose of stepwise regression is to select from a large number of predictor variables to a small subset of variables that account for most of the variations in the dependence of criterion variables. And the predictors variables enter or are removed from the regression equation one at a time. And there are three approaches to the stepwise regressions. The first thing is the forward selections, so which involves starting with no variables in the models, and with testing the addition of each variable using the chosen model fit criterion, and adding the variables whose inclusion gives the most statistically significant improvement, and repeating the process until there are none of the variables which have statistically significant to the models. So backward eliminations will be the second approaches, which involves starting with all the candidate variables and with testing the deletion of each variable using a chosen model variant, and we delete the variables whose do not give the most statistically insignificant deterioration of the model fit, and we repeating this process until no further variables can be deleted. And the first is stepwise solutions, that is a combination. So the forward inclusion is combined with the removal of predictors that no longer meet the specified criterion at each step. So the stepwise procedures do not result in the regression equation that are optimal in the sense of producing the largest R-square for a given number of predictors. Because of the correlation between predictors, unimportant variables may never be included, or less important variables may enter the equations. So to identify an optimal regression equation, one would have to compute combinatorial solutions in which all possible combinations are examined. But the stepwise regression can be useful when the sample size is large in relation to the number of predictors. So here we can see in the example in the textbook, the sex and employment status had the largest coefficients, and as we know that the coefficient has the range between -1 to 1, and the closer to the extreme values, the more effect between them. And here the sex have the coefficient is -0.485, and the employment status have the coefficient of 0.391. So here is multicollinearity part, and multicollinearity arises when intercorrelation among the predictors are very high, and stepwise regression and multi-regression are complicated by the presence of multicollinearity. So multicollinearity can result in several problems, including first is the partial regression coefficients might not be estimated precisely, and the standard errors are likely to be high. And the magnitudes as well as the size of the partial regression coefficient may change from sample to samples, and it's become difficult to assess the relative importance of the independent variables in explaining the variation in the dependent variables. So predictor variables may be incorrectly included or removed in the stepwise regression. So remember, independent variables should be independent, and if there any multicollinearities, so it will cause the problems to the models. And here is the SPSS windows, And as according to the textbook, we'll run the SPSS to the regressions by clicking to the analyze from the SPSS menu bar, and we click regression and then the linear. So we'll move attitudes to the independence. So here is the attitudes and the durations into independence, and also click the statistic. It's the estimate, and we will choose most of it, and the plot we will choose for x and y as the textbook said. We also take for the histogram and normal probability plot. So here's, and we will looking for the R square first, and the R square is 0.876. That means 87.6% of the duration we explain for altitudes. And on the ANOVA tables, we're looking for the sig. So the sig is nearly zero. So that means between altitudes and durations there is relationship. On the coefficient tables, we also looking for the sig. The sig here is below 5%. Yeah, and I will explain the difference between standardized coefficient beta and unstandardized coefficient beta. And for the unstandardized coefficient beta, the number 0.9049 will contribute to the regression equation. So the equation will look like altitude equals error plus 0.59 of durations, and the standardized coefficient we explain for like which factors, which independent variables have the most effect on the dependent variables. So if we have more more factors, so we will looking for the standardized coefficient, and the highest beta will explain for the most effect on the dependent variables. So this is the end of my presentations, and sorry for the annoying sounds, and see you next week.